Okay, guys, welcome back. We are going to do our second video of the week. We are still in the packet unit 9, packet number 1, okay? And we are going to start on page 11 today, okay? So for those of you, page 11, okay? We are talking about exponent properties, which was, if you want to look at your book, Big Ideas, it's in lesson 10.2. Okay, example 1. Multiplying exponents with the same base, okay? And when I say the same base, remember, if you have something like 2 to the 4th, 2 is the base, okay? So complete the chart below. Now, I'm not going to do this entire chart with you. I just want to give you an idea of why this works. We're talking expanded form, where we write the expression as repeated multiplication. This is a review from the other day. We have exponential, where we write the answer using exponents. And then finally, we have standard form, okay? And that's the form you do the math and write as a regular, I say regular in quotes, number, okay? So we have 2 to the 3rd times 2 to the 5th, okay? Let's think of it this way. We have 2 times 2 times 2, and then 2 times 2 times 2 times 2 times 2, okay? 2, 3, 4, 5, okay? The number of factors. Well, how many do we have? Because these are all factors, right, of a certain number. We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 2's, okay? So now you're going to write the answer using exponents. So we have a base of 2, and it's to the 8th power, okay? And 2 to the 8th, if you know that, or if you need to put it in your calculator, you're going to get 2 to the 8th is 256. And for those of you, just real quick, don't know how to use that on your calculator, I have my old one out. I think my high schoolers run off with my calculator. You're going to type in 2, and then you want to raise it to the power. So there's that little, I call it a caret key. It's right below the clear button. You hit that, and that'll raise it to the power. And here, what did we say? 8. Type in 8. Oopsie, there's a glare there. Press enter, and you get 256. Okay, so that's where the exponent key is. Okay, we have another one here. We have, here, let's skip down to this one. 3, and if you have a 3, it's just 1 3, so you can act as if there's a 1 there. Okay, and that's 3, and that's 3 times 3 times 3 times 3 times 3 times 3. Is that 6 of them? 1, 2, 3, 4, 5, 6. Yep. Okay, how many of them do we have? Well, we have 7 3's total, so that's going to be 3 to the 7th power, and 3 to the 7th power, if you pop that in your calculator, is going to give you 2,187. Okay, so I'm hoping you're seeing where I'm going with this, okay? Let's do the next one. 1/4 to the 3rd times 1/4 to the 2nd, okay? Well, remember what I said with fractions. You have to leave fractions when they're raised to an exponent in the parentheses. So we've got 1/4 times 1/4 times 1/4, okay? There's 1. And then we have, or sorry, there's 3 of them. Now we have 2 more, so times 1/4 times 1/4. Okay, how many 1/4s do we have? 1, 2, 3, 4, 5. We have 5 of them. So my base is 1/4. Put it in parentheses, it's a fraction, raised to the 5th power. And that is going to give you, it's the same as saying 1 to the 5th over 4 to the 5th. And that's going to give you 1 over, let's see, what's 4 to the 5th? 1024. Okay. And there you have it, okay? Same thing if you have last one I'm going to do right now. If you have a negative, we've got a -4. So we've got -4 times -4 times -4 times -4 times -4. Make sure you're dealing with a negative, so you put that negative in parentheses. So we have 1, 2, 3, 4, 5 of them. So that's -4 to the 5th power. Okay, negative base, it's an odd power. So we're going to have a negative, and 4 to the 5th is 16,807, I believe. Okay, so compare the above columns and describe if you see any patterns. What I want you to take away from this is if the bases are the same, and we're multiplying, use the multiplying side, you just add exponents. Okay, describe a way to find the exponent form without having to write the numbers in expanded form, you're just going to add the exponents like I said, okay? So for example, if you have 1 to the third squared times 1 to the third, an example of when you could not use it. I apologize, I wasn't reading that correctly. Say we have 1/3 to the second times 1/4 to the third. That's not going to work, and here's why. If the bases are different, can't be, or you can't add exponents, let's say. Okay, so you have to have those bases the same. Okay, let's go ahead and let's flip to page 12. Let's see where we're at here. Okay, so this is called the product of powers property. We're on page 12. Okay, and what that says is if A is a real number and M are positive integers, then A to the M times A to the N is A to the M plus N. Okay, when multiplying terms with powers, if and only if, this is important, the bases are the same, then we can add the exponents to get a simplified answer. So for example, one more thing for fractions. Let's not forget this. Like 1/4 to the third and 1/4 to the second. And numbers with negative signs. We always use parentheses. I'm going to keep saying that because I do not want you to forget that, okay? Remember something else for standard form. If the base is negative and the power is odd, so 1, 3, 5, 7, etc., the answer is going to be negative, okay? If the base is negative and the power is even, the answer will be positive, okay? And number 3, so these are really important things to remember. When a number is written without an exponent, okay, so no exponent. For example, 7, the exponent is 1, not 0, okay? It's 1. So if I have a number, it means it's raised to the first power. Okay, so simplify the exponential expression. 8 to the third times 8 to the sixth. Well, the base is 8. They're the same. So 3 plus 6 is going to give me 8 to the 9th. Okay? Remember, there's no power written, so it's like a 1. We're going to have the same base of 9. So 9 to the 1 plus 8 plus 2, which is 9 to the 11th. Okay? Here we have negative 7 to the second, negative 7 to the first. That's like negative 7 to the 2 plus 1, which is negative 7 to the third. Okay, and it says to evaluate the numerical base when instructed to do so. It didn't in 1 and 2. Now in 3 it says to evaluate. So I'm actually going to take negative 7 to the third. If you have to write it out, you can. It's a negative base raised to an odd power, so it's going to be negative. So negative 7 to the third is negative 343. Okay? Evaluate the numerical base. Okay. We are going to use the commutative. Should remember those, commutative and associative. So let's see, associative properties. You learned those in 6th grade. Okay. So we have 3 and 6. You're not going to add coefficients. You still multiply them just like you always do. 3 times 6. And we have x to the third and x to the fifth. Okay, we move those around. We use the commutative and the associative properties. 3 times 6, your multiplication rules haven't changed, 18. But we know that we add exponents when the base is the same. So we've got x to the 3 plus 5, which is 18x to the 8th. I think, which is kind of fun. Okay, let's go ahead and let's move to page, let's see where we're at. I want to make sure I don't miss anything. Let's flip, we're not going to do page 13. Let's just skip right to page 14, okay? We're going to skip to page 14 in the interest of time, and I don't think you need that little practice chart, okay? Now we're talking about a power of a power property. If A is a real number and M and N, let's see, are positive integers, then A to the M raised to the M power is A to the M times N, okay? So a power raised to a power, you multiply. So if we have 4 to the second raised to the 7th, it's 4 to the 2 times 7, which is 4 to the 2 times 7 is 14. And if they want you to evaluate it, 4 to the 14th, I would pop that in my calculator. Okay, I've got 4 raised to the 14th power Oh, look at that number. Okay, it looks like we've got 268, 435, 456. Okay? Here we have -2 raised to the 4th and then raised to the 5th. Okay? That's going to be -2. 4 times 5 is 20. Okay? So -2 to the 20th power. We have a negative base raised to an even power, so I know my answer is going to be positive. But just to show you, again, make sure you're using parentheses. You have a negative number base. -2 in parentheses raised to the 20th. I'm going to get 1048576, 1,048,576. Okay? N to the 3rd raised to the 4th. That's n to the 3 times 4, which is n to the 12th. Okay? And this last one, m plus 1 to the 5th. Your base is actually m plus 1, okay? That whole thing is in parentheses and being raised to a power. So we have m plus 1, 5 to the second, 5 raised to the second is to the 5 times 2, which is 10. So we've got m plus 1 to the 10th power. Okay? Moving right along, we're going to go to page 15. Okay. So we're talking about multiplying exponential expressions with different bases, okay? Up until this point, we've been talking about the same bases. So again, we have expanded form, repeated multiplication. We have exponential form, which is just simplest exponents. And then we have standard form, where we evaluate the numerical base. So 6a to the 4th. We have a base of 6 and a base of a. Okay, think of it like this. 6a times 6a times 6a times 6a. Okay? We have 6 times 6 times 6 times 6, and a times a times a times a. That's going to give me 6 to the 4th, a to the 4th. Well, 6 to the 4th is 1296, I believe, and a to the 4th. Okay? Again, we kind of just distribute to everything. Okay? We've got 7p times 7p times 7p times 7p. We have 5 of them, right? Okay? That's going to be 7 times 7 times 7 times 7 times 7. And p times p times p times p times p, which is going to be 7 to the 5th, p to the 5th. And if you pop 7 to the 5th into your calculator, I don't expect you to know that, you're going to get 16,807 p to the 5th. Okay? I like this next one. Okay, we distribute that 4 because it's to everything inside the parentheses. So we've got 4 squared x to the 3rd times 4 squared x to the 3rd, 4 squared x to the 3rd, 4 squared x to the 3rd. This is kind of a pain. Okay, I think you can see where we're going. We get 4 squared times 4 squared times 4 squared times 4 squared. We get x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Okay, what that gives us is 4, 2, 4, 6 to the 8th, x to the 12th. 3, 6, 9, 12. Okay, we've got 65, 536, x to the 12th. Okay, we're going to skip all these. Compare the above columns and describe any patterns. You're going to see that you distribute the power to each term in the base and follow the exponent rules. Okay? So for example, if we're on page 16, power of a product property, let's cross that off. We are going to distribute, sorry, we're on page, what are we on? Page 16 here, okay? We are going to distribute the exponent power to each, I'm going to say term, let's write that, term in the base, and then, let's see, let's just follow the exponent rules. Exponent exponent rules, okay? So a b to the m is going to be the same. You distribute a to the m, b to the m, okay? Simplify the exponential expression, then evaluate the numerical base as appropriate, okay? Distributing, we got x to the 2 times 6, y to the 3 times 6. 2 times 6 is 12, x to the 12th. 3 times 6 is 18, y to the 18th, okay? Here we've got 9 to the 3rd, m to the 3rd, n to the 3rd. Okay, that's actually an exponential form, right? Then if we want to get it into standard form, 9 to the 3rd is 729, m to the 3rd, n to the 3rd. And there's your final answer, okay? Here, let's go to D. I like D better. We're going to distribute that 4 to everything. We've got 2 to the 4th, x to the 4th, y to the 2 times 4. Okay, again, that is what we call exponential, okay? Then we've got, well, really simplified, x to the 4th, 2 to the 4th, x to the 4th, y to the 8th. Okay, and then if you want to get it down into standard form, 2 to the 4th is 16, x to the 4th, y to the 8th, okay? And let's do, I think we're getting a little long. We're at 16 minutes. Let's just do one last problem. Let's do letter E. Okay, 3 to the 2nd times 5 to the 2nd to the 3rd. Well, we can't add those exponents because those bases are different. So I'm going to take 3 to the 2 times 3. I'm going to take 5 to the 2nd times 3. That's going to be 6. So 3 to the 6th, 5 to the 6th. Okay, and I cannot combine those. Okay, so I'm actually going to put it in my calculator like this. Let's try to get rid of that glare. There we go. 3 raised to the 6th power. Now, to get that, it's still raised to the power, push the over arrow, and it'll bring it back down. So we have times 5 to the 6th power. That's going to give us a huge number. We've got, let's see. Okay, 11,390,625. Okay, the one thing, I know I said that was the last problem, and it is, when we have 3 to the 6th, 5 to the 6th, we just had to multiply that out. If we would have had something like 3 to the 6th times 3 to the 5th, then we have the same base. And we can do 6 plus 5, which is 11. Okay, so that's the difference between the two. I hope you guys saw that. I think that's enough for today. Why don't you guys do some practice problems, and I will chat with you soon. Take care.